and C if with another F. AB plus BC equals AC.
Right, so this was segment addition basically, right? So we start out the same way, and when we're talking about angle relationship, we can do the same thing. So this is postulate 211, and basically this is angle addition. So just what Hannah read there kind of comes about with angles also. Right? It would make sense that we could do this with angles. So, word-wise, they say D is in the interior of a specific angle, ABC, and then Hannah's if with another F stood for what? If and only if. So D is in the interior of ABC, if and only if what? What has to happen? That the measure of angle, now you got to make sure you write this down, right? ABD plus the measure of angle DBC equals the measure of angle ABC. So again, I don't know if the words mean anything to you, but when I draw this picture, it definitely helps me out. So basically what they're saying is that I have ABC here. If I have ABC, what has to be my vertex? B, right? Because it's the middle letter. So I have ABC here. And they're saying D is in the interior of that angle. If and only if, when I start to do this, I add this angle right here, plus this angle right here, and I get the whole thing. Now, I don't really want to put little arcs there because that means they're congruent. And in this case, it's not necessarily so, right? But we're just trying to show you. So here is my D. And if you notice, ABD would be this first angle. DBC is the second angle. So in other words, what are they saying? The angles inside should add up to the whole thing. And I could have just two angles in there. I could have a multitude of angles. I could have a bunch of them. Okay. The other thing that they might include in here is if some of these would have to be, if it's only two angles, they would definitely have to be adjacent. If you have more than two, some of them would always be adjacent to each other. So right next to each other. But they're going to add up to the entire thing. So just like our segments yesterday, we can now do that with angles. Make sense? Hopefully that one's pretty self-explanatory. So now we start with a bunch of words. So now we go to a theorem though. So this was a postulate again. This is just kind of a rule. Now we had somebody do the math for us. And we got theorem 2.3, which is the supplement theorem. So what's this mean? What does supplement mean? Just in general. Another name for this would be the linear pair theorem. But what's the word supplement mean? From back in when we did vocabulary the first time. Okay? So the supplement means that if you were given a number, the supplement would be what it adds up to get to 180 degrees. Exactly right. So this just says if two angles form a linear pair. Okay? How do I know that they form a linear pair? What do they form if they form a linear pair? A line. Okay? If two angles form a linear pair, I automatically know what? They equal 180 or they are supplementary. Which means they make up 180 degrees. So again now, here's the key to it. Are all supplementary angles necessarily a linear pair? Or do all linear pairs always have to be supplementary? The second one, right? All linear pairs have to be supplementary. If it makes a line, it has to be supplementary to add up to 180 degrees. But if I have two angles that add up to 180 degrees, they don't necessarily have to make a line, right? Because one could be over there and one could be over here. They're still supplements of each other, but they don't necessarily make a line unless they hit each other or connect to each other. Okay? Make sense? So if I have the supplement theorem, what's the next one do you think? Let's see, I don't know if you want to say the opposite of supplementary, but what goes along with supplementary? Complementary. Exactly right. So my next one, 2,4, is the complement theorem. So what would we say here? Basically the exact same thing, except what? Yeah, 90 degrees. So theorem 2-4 is the complement theorem. All right. So if this is where the words sometimes get more complicated than really what they have to say to me. So if the uncommon sides of two adjacent angles form a right angle, the angles are complementary. Oops. No. So again, the words to me, they made it way harder than it has to be. But basically what they're saying is this. If I had adjacent angles here, and how do I know they're adjacent? It means that they share a vertex. So they're saying the two uncommon sides, meaning the sides that aren't touching the middle angle. So if the two outsides or uncommon sides form a right angle, and how would we know that? Gotta have the box, right? Then they are complementary. So again, complementary just means add up to 90 degrees in this case, correct? So again, the box is huge. Especially in our book, because our book doesn't always show us things exactly right. If they don't have the book there, you cannot say that that's 90 degrees. Mine, I don't know if you think it looks like 90 degrees, but now it definitely is when I put the box in there. Okay, can't argue. Theorem 2.5 goes back to what we talked about yesterday. And that is congruence of angles are three words again. Reflexive. What were the other two?
Symmetric.
Symmetric and transitive, right? But now we're just talking about angles. So we said this with segments yesterday. Now we can just do the exact same thing, but with angles. If I have reflexive property with angles, what would I have? Give me an example of reflexive. How about angle 1 is equal to angle 1? Or congruent to it, right? Right? The exact same thing. You looking into the mirror this morning. What's the symmetric property? So when I do what with it?
X equals 7.
Flip-flop it, right? So x equals the measure of angle 2, or we could say the measure of angle 2 is equal to x. We just flip-flop it. And again, this is one thing that we would use if we had to do one more step on the end of our proof, right? Again, when we do reflexive, when we get into reflexive with angles, I don't know if I drew this in your class the other day, but if I drew this right here, does everybody see that that's actually two triangles? The whole triangle and then the little triangle on the top? So the reflexive property in here is saying that if this is angle 1 right there, angle 1 is in both of those triangles. Would you agree with that? Okay, so that's how you would get the reflexive. And then my transitive property again is what? Hopefully we start getting good at this one, right? If angle 1 is congruent to angle 2, angle 2 is congruent to angle 3. If the two middle ones are the same, we pluck those out and we get what?
Angle 1 is congruent to angle 3.
Perfect. Okay. And again, we'll use that one quite a bit. Okay. So again, like I said, we did that with segments yesterday. Now we just show that we can do it with angles too. The next two end up getting used quite a bit, but for whatever reason confused quite a few people. So theorem 2.6 is the congruent supplement theorem. And again, this is where you kind of have to decide if you want to write all these words down. Why this one gets confused a lot is a lot of people would think that this is transitive property, in a sense. But what this is going to say is, and again, bear with me with the words, angles supplementary to the same angle. So just think about that comment right there. Angles supplementary to the same angle. Does that make sense? In your head? Jazz is over here going, heck no, right? So what this is saying is, if I had an angle, somebody give me a number. 12. So if I said angle 1 was equal to 12, its supplement would have to be what? What angle would make it to 180? 168, right? So then it's saying if angle 1 is 12, angle supplementary to the same angle. And angle then 3 was equal to 12. See how both of these have the same supplement? So angles that are supplement to each other, or to the same angle, this is supplement to it, and this is supplement to it. What has to be true about angle 1 and angle 3? It has to be congruent, right? So, where are we at? Angle supplementary to the same angle are congruent. To each other. And if you can write it out like this, it probably makes a lot of sense, right? So what I'm saying is, if I know that angle 1 is supplement to angle 2, and angle 3 is supplement to angle 2, it makes sense that angle 1 and angle 2 are congruent to each other. And again, like I said, it kind of gets mixed up with the transitive property, because we would really say this is supplement, but where it's not really the transitive property, transitive is saying that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. They're not all congruent to each other. They just make supplements of each other, or with each other. So that's the difference. So again now, if I can do it with supplements, I should be able to what? Do it with complements. So theorem 2-7 is the same thing, congruent complements theorem. And again, so we pretty much say the exact same thing, right? Angles complementary to the same angle are congruent to each other. So again, if I had angle 1 is equal to 30 degrees, the complement would be 60 degrees. And then if I told you that angle 2 was complement to angle 3, then I know that that is 30, because they both have to make up 90. So then obviously the first and the last one are congruent to each other. Okay. Theorem 2.8. This one we've done before. Vertical angles, or we've talked about it at least. Obviously, we haven't done it yet. What is true about vertical angles? You remember what vertical angles are? If I draw two lines and they intersect, and I name the four angles 1, 2, 3, 4, what angles are vertical angles to each other? 4 and 2, or 1 and 3, bless you. So, what's true about them? They're congruent. So, vertical angles theorem simply says, I'm going to get lazy, vertical angles are congruent. That's all the theorem says. So we would say angle 1 is congruent to angle 3, or angle 2 is congruent to angle 4. Getting tired of writing yet? So that will last one to do. Theorem 2.9. Now these should all make sense because of previous things that we've talked about. What's that? What did she say?
But they should.
Alright, what's that symbol mean? Perpendicular lines intersect. What's that mean? Cross. To form what? How many? Perfect. See, you knew that one. Right? That was an easy one, right? Theorem 2.10. This one's easy too. All right angles are congruent. Makes sense? If it's a right angle, doesn't matter where I draw the right angle, it's got to be congruent to the other right angle. Doesn't matter how long the sides are, they're still congruent. Okay? That's 2 in a row this time. What you do? Alright, think about this one. This one should make sense too. Perpendicular lines form, if they form 4 right angles, they also form congruent adjacent angles. Would you agree with that? What does adjacent mean again? Right next to each other, they share one of the sides. So perpendicular lines form that. We know that every single time. Told you this was easy, right? 2.12. If two angles are congruent and supplementary, what are they? They're 180, so what do both of them have to be? Perfect. See, I told you, you guys are on fire. They are both right angles. There's no possible way that I could have congruent supplementary angles that wouldn't be 90 degrees, right? Cannot be. Almost none. Theorem 213. If two congruent angles form a linear pair. Think about it again. Two congruent angles form a linear pair. They have to be what? Right angles, right? They are both 90 degrees. Or they're both right angles. Now, when we start doing proofs with all this stuff, especially with right angles, everybody in the world, we would hope, knows that a right angle is how many degrees? 90. But in some, or in most cases, you have to tell that as one of your steps. Or at least use that sometimes. And again, how do we know that it is definitely 90? By the box. Okay? If they don't show the box, I can't do it. Okay? So, any questions with any of the words? I know a lot of words today, right? And again, if you don't like words, you didn't have to write it down, it's in the book. You can always go and look at them in the book. Now again, this is where, if I'm doing this in a proof, how many of you are going to remember all of these theorems by number? Probably not, right? So if you can describe it, it's good enough. As your reason why. Okay? As your reason why. So again, sometimes we'll do these things as easy as basically solving a problem, but at other times we'll use all of these theorems and such to try to do some proofs. Sorry, I didn't mean to say try. We will do a proof. Right, Ms. Hine? Okay, so some of the problems again will look something like this. If angles 1 and 2 are vertical angles and the measure of angle 1 is equal to d minus 32, sorry that got put on two lines, and the measure of angle 2 is equal to 175 minus 2d, find the measure of angle 1 and the measure of angle 2. What are you laughing at? So the key to this whole thing is the first part, right? If I have vertical angles, what's true about angle 1 and angle 2? They're congruent or equals to each other, right? So what do I do to solve? I take my two quantities that are given to me and set them equal to each other and solve. Okay? Is angle 1 and angle 2 two different numbers? Right? Because they're vertical angles, they are congruent. So when you do your math, okay, your angle 1 and angle 2 should be the same number. Now again, remember, when you put the first quantity equal to the second quantity, you're going to solve for d. Is d my answer? Is what we find for d my answer? No. What do I have to do with that d? Put it back in. So again, make sure you answer the question for what is being asked. It says find angle 1 and angle 2. It doesn't say anything about letter D. But obviously I have to find D in order to find the two angles, correct? Make sense? All right, I'm sure I'm going to break your heart, but we'll stop right there and we'll look at problems tomorrow, and then we'll work